Welcome to the lesson on comparing objects. Let's get started. Today we've got 4 learning goals. First, we want to be able to explain how Java stores objects as references. We're also going to learn a new concept called a null reference. Next, we're going to learn how the equal sign compares objects versus primitives and what that means for a method called equals. And finally, we need to be able to explain the concept of an alias in Java. In order to understand how Java stores objects as references, we need to understand first how Java stores primitives. So the computer's memory is divided into slots kind of like an array. And when we make a variable, one of those slots gets set aside for the variable, and the value of the variable is stored in the slot. So that was confusing. Let's see an example. So if I was to make a variable int x and assign it to 5, Java would set aside a spot in memory and label it x, and it would store a 5 in that slot. If I made another primitive, a char ch, it would take the next memory slot, label it ch, and store the question mark character in that memory slot. We also know variables can change. So for example, if I was to say x equals -7, previously it was 5, it would change that memory slot. Now let's contrast how primitives are stored versus an object. So objects are stored in memory in a similar way. Let's take an example. Let's make a string str. We'll set it equal to avocado. So just like a primitive, a memory slot would be reserved and labeled str, which is the name we chose for our string. Except here's what's different. The actual object is not going to be stored in that slot. With x, the -7 is stored in the memory slot. With ch, the question mark is stored in the memory slot. But with the string, which is an object, that won't be the case. What we're actually going to see the slot contain is a reference to where the actual object is stored. In other words, the word avocado does not reside in that memory slot. It resides somewhere else. And the reference functionally is like a link. And when you tap on the link, it redirects you to the location the link points to. So str isn't really an object, it's an object reference that refers to where the actual object is. The idea that objects are stored as references really begs a couple of questions. One question is why, and we'll answer that in a second. But the first question we might have is what actually is a reference? So on the left side of the screen, you will see the memory diagram we had before showing the reference as an arrow. But that's not really what it is. It turns out that every slot in memory has an address, and they kind of look like this if you look to the right side of the screen. So you can almost think of the slots of memory as houses on a street. And just like houses on a street, every single slot has its own address that uniquely identifies it. And so you can see I've labeled these memory slots basically 1, 2, 3, and 4, where X resides in memory slot 1, CH resides in memory slot 2, and string str resides in memory slot 3. But notice again that str, that memory slot, doesn't contain the word avocado, it contains another address. And somewhere else in the computer's memory, we will find a slot with that label of 1, 2, 3. And so this is really what a reference is. It's not storing the object, but rather storing the address where the object lives. The next question we need to ask is why does Java use references? And actually it's pretty understandable why this is the case. So first of all, primitives are generally really simple values. An integer like x is just a number, a character is just one symbol, a Boolean is either true or false. But objects tend to be way more complicated than that. Usually they have multiple values. In the case of the string that holds avocado, we're talking about 7 characters, 7 primitives for that one object, as well as a length and methods and maybe other things as well. And when you put all of that together, it is way too big for one memory slot. Generally speaking, a memory slot can hold one primitive, and an object is way more than that. So the reference points Java to where the object is, and then from there, Java knows how to access all the variables and methods of the object. how exactly that works is way, way past what we were trying to learn in this course, but just for your information, it's called dynamic memory allocation, and it's one of the key features of Java. To give a quick summary of references, all variables in Java are stored in memory slots. Primitives are small enough that they can be stored directly in their slots. We see that with the x and the ch variable. But objects are too big to fit in those slots. So object slots instead contain a reference to the actual location of the object. So str and card in the example, technically we might call them objects, but technically they're not. They're really object references. Now that we have some understanding of a Java reference, we can talk about a special reference called null. And basically, null is reserved for objects that have not yet been instantiated. So for example, on the screen you see string str2. Notice that it hasn't been assigned to a string object, and so if we look at the memory in the lower right, the reference is still there, but since there's no object yet, the reference points to what's called null. Now, str2 will continue to be null until an object has been assigned. And this could potentially cause a problem, but only if we try to use it as if there was an object there. In other words, it's okay that str2 is null. What's not okay would be to say do something like str2.length or .substring, or do anything that would try to interact with an object that isn't actually there. Doing so would cause what's known as a null reference exception. Basically, it would crash. It turns out that null is actually a word you can use in the code. So we know that null is what an object reference points to until the object is created, but we can actually use that in code. For example, maybe I'm concerned that that str2 variable, I want to do some stuff with it, but I'm concerned that there's no value. And so I could write an if statement and I could ask if str2 equal null. And if that's true, I could ask the user to enter a word, for example. And so using null can actually be done to check the status of an object and potentially prevent errors. The fact that objects are stored in Java as references has some practical consequences that we need to be aware of. And the first thing we want to talk about is the use of equal, which typically is used to compare two values and either returns true or false. So to understand how all this works, let's start back with primitives. And in this example, I've made two primitives, x and y, set both equal to 24, and system.out.println x equal to y. And what will happen is it will be exactly what you expect. The result will be true because if we look at those two memory slots, those memory slots contain equivalent values, and therefore Java evaluates this as true. Let's contrast this with objects. So I left the x and y up there, the 24 and 24, and we know that when we compare those two with equal, that we get true because the two memory slots contain the exact same information. However, with objects, things are a little bit different. So I made two strings, str and str2, and I am again printlining str equal str2, which is either going to be true or false. And you might be surprised to learn that in this case, the result is going to be false. And the reason for that is this. The two memory slots, they do both contain references, but you'll notice that they are referencing different objects. And when Java looks at those memory slots and compares them, it sees two different values. In str, it sees a value that points to one memory location. In str2, it sees a different value that points to a different memory location. With x and y, Java saw 24 and 24, two equivalent values. With the objects, it does not see that. Now that we understand a little bit about references, it's pretty easy to see why using equal doesn't work to compare the values of strings, because equal is really just comparing the references, which is why classes, like string but others, will often contain an equals method. And the job of the equals method is going to be to compare for what's called logical equality. In other words, are the objects containing the same values. To summarize, using the equal equal operator, with equal equal, we are always comparing the value in the memory slot. So it doesn't matter if we have primitives or objects, but because primitives and objects are stored differently, how equal equal behaves appears to be different. So with primitives, equal equal is comparing the values because that's what's in the memory slot. With objects, equal equal compares the references because that's what's in those memory slots. And so this gives us the following results, right? We know that x equal y is true because 24 and 24 is the same. We know that str and str2, if we compare them with equal equal, that's false because we have two different references. However, if we do use the dot equals method, str dot equals str2, that will result in true because the job of the equals method, which is in the string class, is to tell us if those strings contain equivalent characters. The last thing that we need to discuss related to references is the idea of what's called an alias. And if you know the word alias as it is just typically used in the English language, we know that alias means another name for something. Spies often have aliases, a name that they go by that isn't their real name. And so that will kind of relate to what we're talking about here. So let's consider the example. So I'm leveraging an object called point in this case, and a point just contains an XY coordinate. So it's a very simple object, but that really doesn't matter. The first thing I do is I make point P1 and I set it equal to a new point 0, 0. And so you can see that I have updated the memory so you can see that. In the second line, I create a second point object called P2, which also stores the point 0, 0. And finally, and this is the one you really need to pay attention to, I say point P3 equals P2. Now, what is that going to do? Well, it turns out that when I say P3 equals P2, I'm going to get this. See, copying one object to another really is not copying the object, it's copying the reference. P3's memory slot took on the same value of P2's memory slot, and notice what I get is two references pointing to the same object. This is what we mean by aliases. So now we have some print lines where we print line, let's take a look, we print line P1 equal P2. Now if we look at those two memory slots, we see two references, but they reference different objects. So we get a false. And in the second print line, we do P1 equal P3. And again, we see two references, but they're referencing two different objects, so we get false. Finally, we print line P2 equal to P3, and those two references refer to the same object. They're called aliases, and now we finally get a result of true. To check your understanding, take a look at the code on the left. You'll notice that there's 4 print lines in that code, and I'd like you to pause the video, take a few seconds, and really think about what things are going to be print lined. Think about the memory, think about aliases, and when you're ready, unpause the video and we'll see the answers and talk it over. All right, let's see what we got. So here's the answers first of all, but let's talk about why those are the answers. So the first thing I do is I make a string variable str1 and set it equal to sour cream, and then I make str2 and set it equal to str1. Setting one string equal to another, or I should say one object equal to another, copies the memory location, which in this case is a reference, and so we get an alias. str2 now has the same reference that str1 had. So when I print str2, we will notice that because it points to this object, we get sour cream as our answer. And then the next thing I do is I say, does str1 equal str2? And that is true because we do have two references pointing to the same object. Next, we do str1 equals str2, which compares the value. Functionally, we're comparing the value of an object to itself, but it is indeed the same value, so we get true. And then the next thing we do, this is where it gets a little tricky, is I say str2 equals a new string sour cream. And so I want you to see what that does, because that functionally makes it so that the link is broken. str2 no longer points to that first object and now points to a new string object called sour cream. And so this time, for my final output, when I compare with equal equal, I get false because the references are no longer pointing to the same object. Thanks for watching. Now that you've done this lesson, you should be able to explain how Java objects are stored as references, explain the concept of a null reference, explain how objects are compared using equal equal as well as the equals method, and be able to explain the concept of an alias in Java.